All right, so let's go ahead and get started. We'll, go through these opening slides, and last couple people can trickle in. But welcome to the 9th General Body Meeting of the year. If you haven't yet, sign in our attendance form at acm@uc.org/c. So, as always, we have our resources. We are recording right now. We also have our slides that we're going to, and all of that will be available through our archive after the meeting. By now, you know, ACM-UC is the student chapter of the Association for Computing Machinery at UC. Computer science and programming is our thing, but anyone is welcome. And we have tech talks like this one, workshops, hackathons like Revolution UC this weekend. It's virtual, February 20th through 21st, 24 hours. You can get a team, make a project, or just have fun going to mini events, whatever you want to do. Either way, it's going to be super fun. We've got lots of awesome sponsors, and you can see all the details and sign up if you haven't at revolutionuc.com. And today, we just got details about ICPC. That will be on March 6th. That's a Saturday. And the teams, like they always are, they're teams of 3. So if you want more info, you can go to that link, which you can either look at right now, or you'll be able to click it once we post these slides. And if you have a team and you are want to sign up, contact Dr. Franco. His email is there. So as always, our code of conduct applies in meetings, in Slack, in Discord, anywhere where we are a community. So it basically just means be cool, harassment-free experience for everyone. Just, don't don't make anyone feel uncomfortable. And like we've been doing all year, since we have virtual meetings, no pizza, but we still want to give back to you guys. So we've got raffles. So stay around and sign in at acmuc.org/c, and you'll be entered to win a gift card. And so, like I mentioned, our main forms of communication are Slack and Discord. Slack, you've got lots of messages in different channels, general, random, off topic, homework help. And Discord we use for social events, and office hours, which will be happening at 8 o'clock right after this. So join us there. And we'll be chatting tonight about getting started at a hackathon, maybe how to work your way through it, not spend too much time on one thing at a hackathon, because it's only 24 hours. You got to prioritize what you do in that time. And also just anyone can share their experiences at hackathons. It'll be a fun chat. So other resources we have, like I mentioned, we have our archive, our resources on our website, and also our YouTube channel, which is where, if you're watching this not live, that's where you're watching this. And so that's all I have. We're going to hand it over to our speaker, Bharathi Saravanabhavan. I think I got it right. He's going to talk about versatility of engineering and his experience of transferring from biomed to software engineering.
All right. Thanks, Brandon. Let me put up some slides. Well, this is awkward. It's asking me to restart Teams in order to share my screen. So if you guys can just give me...
Oh, for permissions. Yeah.
Yeah.
That's cool.
Yeah. Yeah, I'll be right back in a couple seconds.
All right. Awesome.
All right. Until then, who here already signed up for the hackathon? Do you guys have teams? Do you guys have ideas that you are comfortable sharing?
I'm not sure this is a good practice, but I like to walk into hackathons really blind. So the brainstorming just kind of blows up in your face and you're like, oh, my 24 hours is just going to be up to brainstorming. It's very stressful.
Yeah, but it's a good way to like pressurize yourself into making a decision.
True, true.
Yeah, it's been multiple cases that like myself and a couple other friends, we were like planning on going to a hackathon, but then before the hackathon, we just spend a lot of time trying to discuss what we are going to do. And if we don't come up with a good idea, we probably just cancel going to the hackathon. So I think it's a good idea just trying to go in blind.
Did anyone else get a pop-up where their Bharathi needs to be admitted?
Yeah, it's not letting me admit him. It just sits there saying admitting for like a minute and then fails.
Yeah.
Is this because he's a guest? No,
oh wait, did that work? There we go. Okay.
Yay.
There we go.
Yeah, I denied it so that like he can probably try again.
Okay. Yeah.
You know, the good old turn it off and on again.
Yeah.
Okay, cool. So let's see if I can share my screen now.
There we go. Awesome.
All right, great. Let's see, how do I want to do this? I'm going to put it in presentation mode. Let's see if that works. Can you guys still see?
Yep.
Okay, awesome. Anyway, so I've only got one monitor, so I can't see the Teams meeting, so I'm just going to have to stare at a PowerPoint presentation. But anyway, my name is Bharathi Saravanabhavan. Props to Brandon for getting my last name right. But I'm a software developer at Johnson & Johnson Ethicon. I actually worked with one of your members, Jihad Khan, for a couple semesters. So that's kind of how I found myself, here, right? So when I talked to Jihad, it was, he had asked me, if you can give a talk for 40 minutes or so, and I was just, contemplating what can I possibly talk about at, during this time that's interesting going on. But honestly, thinking about it, I'm probably not that much older than you guys, but my background is a little bit, different from the standard software developer. And I think I've learned a lot of lessons along the way that could probably be applicable to you guys as well. So really, I just wanted to talk about my journey and, the lessons that I've learned along the way. And then, some things that hopefully you guys get to glean off of that. I'm going to keep it totally casual. If you have any questions, feel free to jump in. And I'm sure there's going to be time at the end to ask some additional questions. So, to kind of summarize all of that, the topic is versatility in engineering, transitioning from biomed to software engineering. Cool. So a little bit about me. Well, you can see there's a picture of me if you can't see a picture or a video of myself. But obviously pre-COVID times, I'm not wearing a mask. But I graduated from Georgia Tech in 2018. So just about 2.5 years at this point. And out of that time, I've worked at a couple companies, and J&J being the second one. So I grew up in Atlanta, that's where I'm from. I've been in Atlanta pretty much my entire life. So moving to Cincinnati was a big move for me, right? Because I hadn't really ever lived anywhere outside of Atlanta other than, a couple semesters study abroad. But So this was definitely a big move, and I've learned a lot working at Johnson & Johnson. So that's a little bit about my professional experience, I guess. Other than that, on the side, I'm like a part-time photographer as well. I actually really enjoy music, and I think some of those things, like those artsy, creative things, actually kind of tie into my professional experience as well. Maybe I can shed some examples there. But that's a little bit about me. And with that, I can just kind of go ahead and get started about my journey, I guess. So yeah, anyway, how did I end up here as a software developer? So I remember it was all the way back in high school. I had to decide, what major I wanted to do in college. And for some of you guys, I mean, maybe some of you are freshmen or early in your college career, so you can kind of take away what you want from this. But I could never see myself as a software engineer. And it's kind of ironic because I remember having conversations with my dad because he's a software developer as well. And just seeing the way that he worked, like he would put in a lot of hours, right? And I mean, that was just his work style, right? Like he would work during the day and then he would come back home and work for a little bit as well. And I just could never see myself doing that. And I kind of normalized that to some extent. And I basically straight up told him, like, I'm never doing software engineering. Like, this is just not meant for me, right? But here I am. So as part of that, going into college, I had a lot of interest, right? Like I always enjoyed development, like as a hobby type thing, but I could never see myself doing it professionally. So I wanted to do something a little different. I was also interested in medicine at the time. And I mean, that's kind of the case, right? When you're going into college, like right from high school, and you might have kind of an idea of what you want to do, but I mean, you don't really, right? Like until like towards the end of your college career, do you really figure out what you really want to do? But so medicine was kind of an option for me. Like I was thinking about doing pre-med and, going to med school at some point. But at the moment, I didn't want to commit to that. And that's kind of where biomedical engineering kind of came in, because it gave me an opportunity to, use some of my, technical skills, right? Whether that's like software development or engineering skills that I had just picked up along the way. But not necessarily commit to like medical school or something, right? Because it was a good hybrid. And there was a lot of satisfaction with going into BME as well, right? It's not just the fact that I get to be an engineer, but also the fact that whatever I work on could be potentially influencing or saving even thousands of people's lives. So that's the direction I decided to go in, and to this day, I don't really regret it because it's what got me here. So that was my decision in going into college, right? Start off with biomedical engineering, let's see what happens there, and then kind of just build off of that. So what did I do in my undergrad experience that kind of changed all of that? So there were a lot of experiences in undergrad. The first big professional experience, I guess, to some degree, you can say, was working in neuroengineering lab. The name of the lab is pretty self-sufficient, but essentially we were there were several researchers, but the researcher that I was working with was interested in how we can use biological or electric signals from the brain to categorize certain things or even control certain things, right? So the project that I was really involved with, and it's a pretty cool project, is we were developing a device that was geared towards treating, or at least attempting to resolve some of the symptoms of diabetic neuropathy. And diabetic neuropathy, just kind of at a high level, right, is a condition that develops when you have diabetes for an extended period of time. And basically what happens is some of the nerves in your body, and typically it's like in the peripheral parts of your body, right? So like your fingers or your toes or like your feet start getting damaged, and they get damaged to the point that you can't feel anything anymore. And typically that happens the most in feet. And what happens is over an extended period of time, if it never gets treated, it'll start building up up your leg. So it'll eventually could even, go crawl up all the way up to your thigh. And the issue with that is if you can't feel anything in your foot, then, if you stub your foot or if you step on something, you're potentially going to get injured, and likely you won't even know that you got injured. And it's kind of like a positive feedback loop, right? Like you get injured and then you don't realize that you got injured, so you keep getting injured. So what happens is you form ulcers, or even in worst cases, it can lead to amputation. So what we wanted to do was develop some kind of device that could stimulate the foot to provide a sensation back into the foot. It doesn't have to be like real sensation, right? But at least something that can help you feel, like where your foot is when you're walking, or how your foot is with respect to the ground. So what we did was we came up with this device, right? It was basically like a pad that you can put inside of your shoe. And that pad, like based on how you were stepping on it, it would have pressure sensors and things like that. That pad would send electrical signal to some of the nerve endings in your ankle. And by doing that, you're actually stimulating your foot. It's really cool. But we didn't have to go invasive or anything, right? These were just like patch electrodes that we put on the ankle. So when you tested it, if you put your foot down, you could actually like start to feel a sensation. And that's kind of when I realized like there's so much that we can do inside of the biomedical landscape, where we apply like modern day technologies, right? This wasn't necessarily software development, but it was kind of in the vein of things. So that's when I started to realize that, and started to get some more of an interest in it. So I think that was definitely a turning point in my undergrad experience. But on top of that, there were some co-op experiences that I worked with, right? So one of mine was Boston Scientific. There was actually primarily just working on mechanical engineering and design type of work. And after a certain amount of time, I started to realize like, hey, this is cool, but like, I'm not really solving as many problems as I thought I would, right? It's not necessarily as glamorous as that I thought it would be. So that kind of triggered me to kind of go down that track again. Like maybe we can start looking at some software development techniques or something that we can apply to the biomedical landscape. And even prior to this, right, like software development was still a big part of my like educational experience, I guess. Like I had done some work like in senior year of high school, for example. We had to develop like a capstone project where we developed like this mobile application. It's like a educational game kind of thing. And even before that, like because my dad was also like into software development, he started to teach me some of that stuff, like even as early as middle school. So like I had some experience going into it. So with that, and like with some of the experience that I had in the neuroengineering lab and with Boston Scientific, I was just like, okay, let's do it. Let's go for it, right? So I signed up for a computer science minor at Georgia Tech, and it was specifically within the intelligence track, and it's like AI and machine learning type of stuff, which I'll get into later. But that kind of helped me propel my, professional desires, right, to contribute to the medical device landscape with computer science. So I got started with the minor, started taking some classes, and that's when I started my second co-op with Halyard Health. There I was, again, a biomedical engineer, design engineer co-op, but I actually got to flex some of my computer science skills. It wasn't a whole lot. We were working with LabVIEW really. So it was a graphical programming language, but the principles still apply, right? Like you still know how to come up with algorithms and stuff, and just the logic of, or the just knowing how like data moves around and stuff like that. So all that stuff still applied, and I got to work on these little guys that you see on the screen right here. So this thing on the left was the old device, which we then renovated, or I guess even reinvigorated into this newer device right here. But basically what it was is, it's kind of funny because it actually ties back to the neuroengineering lab, but it was a pain, I guess you can say pain relief device, long-term pain relief, but essentially like you can build A lot of people get things like back pain, for example, right, or nerve pain in their thighs or whatever, to the point that it's just unbearable. So they'll come in for treatment to resolve that, right? So one of the ways to do it is to actually insert probes like into the back or into like your thigh or whatever, and you apply radio frequency energy to it. And by doing so, you're actually, in a sense, ablating that that nerve tissue. And by doing that, it's almost like you're killing the nerve tissue, but by doing that, you start losing sensation in that part of that body, and that will help mitigate some of that pain. So it's really designed for long-term pain relief. So I got to work on updating some of this guy right here. So I got to work on a little bit of the UI. It was mainly on the quality side of things. I didn't really get to do a whole lot of development, but I did get to oversee some of the designs and the thought process behind those designs and validating them. But one thing that I did was, on top of this little device on the right side right here, you see the secondary device up here. It's a pump, and that pump is used to pump water through the probes. And it's part of the whole technology. I'm not going to go into details about that, but essentially we found out that if we can somehow control the amount of water and the flow of the water that's going into the probes, we can actually create better ablations in the body that lead to long-term or even longer-term pain relief. So my job was to come up with an algorithm to actually do that. So I got to take in some inputs like like the resistance of the tissue, like the heat of the tissue and things like that, and come up with an algorithm that actually predicted like the flow that we could use to basically, we come up with an algorithm to control the flow of the water that's going through the probes. And I thought that project was incredibly cool, right? To the point that this was, I'm not sure if they ended up using my algorithm, but to the point like that the idea carried through, and it actually got implemented, and then the pumps were called like smart pumps at this time, and they actually went out to market, right? So I thought that was just phenomenal experience. But that kind of reinforced the idea of, hey, let's take these smarter software development experiences and apply them to the medical device landscape. So that kind of like sealed the deal for me, and that made me like pretty satisfied that I'd gone and done the computer science minor. And I think over the long term, that's actually had a pretty big effect on my like even my full-time career choices. The other image up here, don't have to get into details about it, but it's the EMBC, it's the Engineering Medicine Biology Conference. It's a conference hosted by IEEE, where I actually got to present some of my work in the neuroengineering lab. So I thought that was really cool. Just put up a quick logo. Cool. So lessons learned. So I kind of just rambled on there for a sec, but really the main thing that I learned is start thinking about how you want to contribute to the industry as soon as possible. Right. And for me, that was applying these smarter, potentially AI or machine learning techniques into the medical device landscape. Right. That was kind of what I wanted to do. Right. And it took me a while to get there. Right. It's not something that I had known like coming into undergrad, like I mentioned. It's not something that I even knew like during my second year. Right. It took me some time to figure that out. And that's completely okay. That's what college is for. But start to have kind of an idea, right? That was my takeaway anyway, is it's good to have that idea like right around the end of college, like what kind of, like I'm guessing most of you guys are planning on becoming software developers, right? But what kind of software development do you want to do, right? Like what field do you want to go into? What are your skills, and do you want to continue building on those skills, or do you want to learn some new skills and apply it in the industry? So really anything is possible. So just start thinking of what you want to do and just try to come up with a game plan of getting there. That's kind of how I treated my undergrad experience. A lot of it was on the spot decision making, but eventually it started to all kind of come together, right? It streamed all together, and that's kind of what helped me get to where I am as far as undergrad is concerned. And yeah, for me, that was, like I said, software and medical devices. So I've got a dog in the background, so if you hear any weird noises, it's probably her. Just letting you guys know now. Oops. So right out of college, right, I started working at a startup called Vero Biotech. They were housed in Atlanta. I've worked there for about 7 months, and man, that was something else. I worked there as a systems engineer, and as a systems engineer, it's pretty cool because it was pretty much the application of almost everything that I had learned onto a medical device, right? So that's kind of what systems engineering is like applying different parts of engineering together to come up with some kind of product or help like qualify or validate some kind of product. So I'll get into the startup environment in just a second, because I imagine some of you guys probably have questions about that. But we were working on a nitric oxide drug delivery system. It's complicated, I'll just say that, but it's essentially the only way to administer nitric oxide, and even to this day, right? The most commonly used technique is through big canisters, right? Like literally, like, you know, if you see like oxygen canisters in like a warehouse or something, or it's kind of similar to that, right? It's very large canisters. If you accidentally bump into it or something, it's a huge hazard. And if you imagine, like, these things are used in the ICUs, and if they're, you know, carting this stuff around and it gets bumped into something, you know, it could be potentially life-threatening. So what this company was working on is coming up with a way to kind of make that whole system portable and get rid of the canisters. So what they came up with is this device, and within this device, there's a whole slew of pumps and valves and all this stuff in there that controls the drug delivery. But it takes basically a capsule, like a solid capsule, and converts it into nitric oxide gas through chemical reactions and stuff like that that are all contained within the housing, and delivers it to the patient. So, and as a result of that, you can actually just get these things that are like cassettes, right? If you guys remember what like VHS tapes look like, basically something like that, right? You insert it into the unit and it'll take care of everything. So I got to work on this system, which I thought was really cool. When I came into the company, this was already developed, but what I got to really work on is an ambulatory version of this, right? So an even more portable version. The idea was eventually something that was like the size of your phone, but I don't know if we ever got that far. But I was kind of at the front end of it, right? Front end being like the very early stages of development. So my manager, when I joined the company, right, there was only 3 systems engineer at the time. One of them was in Florida, so they were not on site, so they were doing some other work. And then the other guy, he wasn't working on this project. So pretty much it was just me. So I had to come up with a prototype of a device that could turn on and off pumps and valves, read accelerometer data that came in from external sensors, and stream all that over Bluetooth over to a mobile device with a mobile application. So that was a lot of work. And I knew like I could do the mobile application and stuff like that, right? Like I had experience doing this. But as far as like coming up with the actual device itself, like getting a microcontroller and, you know, building that out, like that stuff was completely new to me. That side of software development, like embedded work, was just, you know, beyond anything that I'd worked on, right? Like I know like I had taken one C++ class at Georgia Tech, and that was kind of my extent as far as like embedded stuff went. Like, and even then we weren't really doing embedded development. It was just, you know, understanding low-level programming. So that was very new to me, and that kind of goes back to the startup environment, right? So if you guys are interested in working at startups, like it's a really cool opportunity to learn a lot of stuff really quickly. But there's going to be little guidance, right? Like I said, like I was the only guy on the team working on this, so I had to like come up with something. So I had to learn a lot of stuff. Like I was, you know, talking to some like computer engineering majors outside of work. You know, I was just doing a lot of research, like even outside of work, to come up with some ideas to get this thing rolling. And eventually I did come up with a device, right? It was pretty cool. But I just remember when my manager came up to me and he was like, hey, look up like a microcontroller SDKs, I think they were called. And I just looked at him like completely baffled because I didn't even know what that meant. Like to me as a developer, an SDK is like something that you develop on a computer, right? It's tools that you use to develop software. But when he said that, this was actually literally identify a microcontroller, see if you can find a kit of microcontrollers that you can develop on, buy some sensors for it. So it was literally ground up, right? So I thought that was really cool. That gave me a completely different perception of, software development. And I think that was, unique to working at a startup and unique to working specifically at a medical device startup. So even up to this point, right, I wasn't even a software developer, but still a systems engineer. But, you kind of get the idea, right? Like I'm starting to build up those skills. So yeah, I mean, in the end, I finished that project. Like I came up with a device using some TI microcontrollers. I think it was like a Bosch accelerometer kit, which was also very hard to communicate with. And if you guys ever do embedded development in your careers, there's very little documentation. There might be some examples, and anything that you do is probably just copying examples over and changing them up for your use case. So just FYI there, or get ready to read a lot of docs, like long documentation. But it was a really cool project, right? I got to read an accelerometer data. I got to learn how Bluetooth works, how Bluetooth tables are transferred over, over the air from like a microcontroller over to a cell phone. Developed an application on React Native, and although it wasn't real time, but got near real time like accelerometer data back. I could click buttons on my phone that turned on and off pumps and stuff that were connected to the microcontroller, and even to some extent got to work on some of the electronics, which again don't have a whole lot of experience with, but I started to learn some of that stuff, which I thought was pretty invaluable. So the lessons there is I got to build a lot of technical skills. And what I like to say is as an engineer, as a software engineer, you're really just building or you're creating your tool belt, right? And every skill that you learn is a tool that you can put in your tool belt. So I know in the last lessons learned, I said, start to hone down on what you want to work on, or what industry you want to work on, what skills you want to apply. That's great advice as well. But also, once you've kind of started to hone that down, start to look at how you can broaden that experience as well, right? So start to become an expert in something, and then once you've gotten going, try to expand and find some other skills that you can work on, because inevitably you're probably going to be using it at some point. And that's kind of what I learned from this experience is I might not be using embedded development anytime soon from that point in the future, but it's a great skill to have. It taught me a lot about how computers even to some extent work, how data is handled, how things like Bluetooth work, all that stuff, right? All part of modern day technology. And just in general, when you go into the landscape, right, my advice to you is be prepared to work on things you would have never imagined, right? Like when I started working at Vero, I told the hiring manager that, hey, like I'm interested in software development. I'd love to be placed on projects that let me exercise some of that. And they spun this whole idea of using machine learning to determine like the dosage and things like that for this nitric oxide. And at that point, we were ready for that. So even though that was something that had pulled me in, I ended up doing something completely different, right? I got to build the device kind of from ground up. So that was really cool. So, but you're going to inevitably face that at some point in your career. So be prepared for that and just be flexible enough to learn and get ready to find those resources, right? Because that's what's going to make you an exceptional engineer, an exceptional developer. All right, so then moving on. So this was my first role working as a software engineer at J&J. So to this point, right, I never worked as a full-time software engineer. And when I was at Vero, after 7 months, I was starting to feel like I was ready to move on. I'd worked on this project, and then I got placed on some other minor projects that I wasn't super into. And I started to realize, like, hey, like, I actually want to apply some of this stuff full-time, right? Like, actually as a software engineer. So that's when I started applying to companies like Johnson & Johnson and, some other medical device companies, right? And I just went for it. I was like, okay, I think I've got enough experience. Let's go sign up for an entry-level software engineering role. And that's what I did, right? And I ended up getting the job. And that kind of just surmises everything, right? It all started way back in like senior year of high school, like working on the senior design project, and then working in this neuroengineering lab, and then some of my co-op experience, and even my senior design in college, and so on, right? Like all of this kind of came together to this one role, and that's why I was saying, like, I don't really, even if I wanted to do software development, I don't regret choosing an engineering background, because it helped me get where I am now, and in a sense, it gives me a different perspective on things too. But anyway, my experience at Johnson & Johnson is completely different from working at Vero. There are some similarities, and I'll get to that in a second, but overall, like, just different work-life balance, work style, everything is just different. And specifically at J&J, I'm a software engineer on the test engineering team, or the tools and infrastructure team, where essentially that kind of sums it up. We develop tools and infrastructure for robotic devices, right? So this image that you see out here on the left, that's it's a system called the Monarch system. You can check it out online. It's it's all public information, but it's used for robotic surgery. And we're actually working on a whole nother system outside of Monarch. It's a developmental project, hopefully in market soon, that kind of revolutionizes this whole system. So I got to work in that project, right? And that's still working there. But we basically develop tools and infrastructure for the development and the testing of the surgical tools. So like the tools that actually get attached to the robot. I don't have a picture of that here, but imagine if there was like a stapling tool attached to the end of this or something, right? Not like a physical stapler. It looks different, but you got the idea. But yeah, like a surgical tool, like scissors or something attached to the end of this. Our goal is to develop kind of a platform that allows you to test that and develop that on a robotic platform. So as part of that, we develop things like APIs, right? APIs for controlling the robot, or like high-level APIs built on Python, or even like to some extent writing some of the lower-level C++ controls code. And even if occasionally, if we're lucky, you get to work on some of the actual robotic hardware as well. So it's a really cool experience. And because we're working on tools and infrastructure, we're constantly learning new skills and applying it to this this platform that we're developing, right? So when I started working there, I was working on writing some C++ code that would basically gather data real time and give you access to that data over different platforms, or different front end, or I call it front end, but like front end tools like Python or GUIs or whatever, right? It gave you real time access to robotic sensor data, which was really cool. I got to learn about how operating systems work and some of the considerations you need to take when you're working in a real-time environment, and things like that. So that was my first project. And then I've had several projects since then, but a couple defining projects outside of that, I would say, is I then started working on DevOps, right? So for you guys that might not know what DevOps is, it's development and operations, but it's the how do I want to say this? It's the idea that you can combine development and operations all into one work stream, right? So development being like writing the software and to some extent testing the software, up until deploying, right? Once you get to deploying, you kind of go into the operations side, where you deploy software out to whatever your environment is. You monitor your software over time, maintain your software, all that stuff, right? It's the idea that you can do all of this in one work stream instead of having two separate functions for that. So I got to work on pipelines and things like that that could build your code and deploy your code and test your code and all that kind of stuff. And what was really cool there is working in medical devices, it's a primarily mechanically oriented industry, right? Even if there are software engineers, the engineers that kind of drive the industry are mechanical engineers. And kind of going back to undergrad, right? That's why I wanted to contribute to this space. Is there's a lot of technologies that we can apply that we aren't applying in this industry. But anyway, working on DevOps, it made me realize that even more, because as soon as I started working on this, I realized like, hey, this could actually be kind of the cornerstone for building culture within Johnson & Johnson, software culture within at least our franchise of Johnson & Johnson. And that was kind of what ended up happening, right? Like by building out this infrastructure, I was, teaching these mechanical engineers how to use Git, how to use Bitbucket and do pull requests, and how to use how to build your code in a consistent manner, have it tested, how to run your code through pipelines and stuff like that. Like that started to build a culture within the company, right? And it's still not fully there. Like there's still a long way to go, but it kind of got it got the ball rolling. So I thought that was a really cool experience, and hopefully that kind of sheds some light on how the medical device industry is oriented to you guys, if any of you are interested in working in that space. But other than that, it was just a very diverse set of experiences, right? So I got to build tools on the cloud, like using Microsoft Azure. A lot of the DevOps work was done on the cloud. Got to work on some data processing pipelines, and start to apply potentially some of the skills that I'd picked up from university within that machine learning and AI space. So I think working at Johnson & Johnson, like it's just given me a plethora of opportunities to kind of build on my software development skills, are kind of geared towards that medical device landscape. But having done all this, the reason I say that J&J is different from Vero is there's just working at a bigger company, there's this perception that things tend to be slower, and I'll explain why it wasn't the case working on this team. But you also get like the big company culture, the benefits and all that stuff like that, right? So as far as culture goes, maybe it's not a software driven culture, but the culture of working at a bigger company, it's very focused on you as an employee and things like that, and Johnson & Johnson does a really good job at that, so that was really appealing. But at the same time, like working on this robotics project, it was kind of like working at a startup as well, because a lot of the stuff that we're doing is not out to market, and we're like really pushing to get out to market. So it's always like, go, get this stuff done right now. But at the same time, like everyone understands like, hey, like, people need to leave at like 4 p.m. or 5 p.m., right? It's not like Vero where I was working after hours and things like that. So I started to see some of that. So it's kind of like a good hybrid between like working at a traditionally big company versus a startup. And I thought that was a really cool experience. And that's the reason why I'm still here today. But yeah, I mean, all of those experiences kind of helped me get to the point that I'm where I am today. And I've gotten to build a lot of skills along the way. And I think a lot of you guys will kind of experience the same way. So that's kind of why I'm sharing some of those lessons learned. Anyway, so as far as J&J is concerned, I kind of talked about the second point, but the first point I didn't really get into too much is software quality, right? I really started to understand the importance of the quality of software that you're writing, right? Like in college, we weren't really writing software that was meant to go to the field or, to someone else's hand or might change someone's life, right? versus working in at J&J. Like that's such a big deal, right? Like every piece of software that we write needs to be replicable. It needs to be understandable. If you were to leave the company for some reason, someone needs to be able to pick it up and understand what you're doing. So that made me start to realize like the importance of software culture. And I kind of mentioned this at the beginning, like I really like things like photography, music. I actually really like learning languages and things like that. Like languages, not like software languages, but like, spoken language, right? I actually really like that kind of stuff. And I got to kind of directly apply that to the software that I was writing, right? If I'm like writing APIs, for example, right? I have to really focus on how I construct the experience in a manner that's understandable to the end user and provide, in a sense, it's a language in itself, right? Provide a language that's, understandable by the end user and that they can apply it and, teach other people and things like that. So I had to kind of exercise like some of my creative skills there. And that actually kind of started to hone in on the idea of quality, because when you start to focus on like the big picture when you're writing software, and start to understand like how important it is for readability and understanding your code, and being able to replicate your code, like the quality starts to come with it. And with the quality, the culture starts to come with it too. So once you start doing that, you can start focusing on your development practices, right? You can start focusing on how to properly use things like pull requests or, run your code through static analysis tools and make sure there's no bugs and things like that. All of that starts to come with developing better quality software. And over the long term, you can build a proper software culture in that manner. So that's kind of my takeaway, right? My suggestion to anyone in college, right, is to start to learn software development practices early, because that's going to be pretty fundamental. When I've recruited for students in the past, like both co-ops and really mainly for entry-level engineers, I really look for an understanding of development practices, right? Do you understand how to contribute in a team environment? Do you understand, like, if you were to make a code change for this specific feature that you're working on, how that's going to affect someone else or another team member? That is really more important to me as an entry-level engineer than, knowing how to write a complex neural network that's, going to classify robotic data or something, right? I just want to be able to see engineers, come to the floor, understanding how they're going to be able to fit in to a team environment and start to build software and start to build a software culture, especially in an industry that's so mechanically driven. So conclusion, I think as an engineer, with this background as engineering, it's given me kind of a fresh set of eyes on software development. I think I have a slight edge when it comes to quality, just because having worked in a biomedical engineering space where, everything that you do is basically, someone's basically overseeing everything that you do, and that someone's usually the FDA, right? So you have to be very careful, and you have to make sure whatever you're doing is up to par, documented. There's standards that you adhere to, and overall you just stick to the company's quality policies, right? So that kind of gave me an edge working in a software development environment, because it's not always going to be code. It's not always going to be designing architectures. There's going to be some times where you have to start thinking about testing your work and validating your work and writing up that documentation. So I had a little bit of an edge there, and the main takeaway there is, again, when it comes to quality, start thinking about that stuff early rather than later. And yeah, I mean, the main point is anything is possible. Just focus on your goals, right? Start to think about what you're interested in and just come up with a game plan to get there. And eventually you'll get there no matter how long it takes, right? Because that's kind of, I mean, my journey is like not even close to being over, right? Like I still have a lot of things that I want to do, like potentially go to grad school. I still haven't really gotten to use some of the machine learning or AI that I want to inside of the industry, but I've started to build some of those skills, over the past 7 or 8 years, right, to this point, to kind of get me there. So just continue to focus on that, continue to build those skills, and continue to just craft away at those tools in your tool belt, and eventually you're going to get to wherever your goals are set. That's pretty much it. I feel like some of it I rambled on a little bit, but that's just because there's when it comes down to it, there could be a lot to talk about. But thanks guys for listening in. But we can, I guess, if you guys have any questions, we can do that now. I think we've got a few minutes. My email is also up here, so if you have any questions, feel free to reach out. But other than that, thanks for listening.
Yeah, thank you so much. That was an awesome talk. That makes me feel refreshed. It's always nice to hear other people's experiences. Yeah,
for sure. Yeah, thanks again for having me.
Yeah, so we've got a couple questions here in the chat that came in. So I guess, if you're not sharing your screen, you can probably see those now.
Yeah.
So what courses have you taken in CS in college, or have you completely self-studied? So you said you had a CS minor, right? So I guess were any of those classes that you took very essential to your, you use that knowledge later on, I guess?
Yeah, that's a really good question. This is actually a point that I wanted to make, but I didn't get to. But let me make 2 points. The first thing is, like I said, I've recruited a lot of different engineers for co-ops, entry-level positions, even senior-level positions. But one thing that I've noticed is a lot of students coming out of college, they were kind of like me, right? Like they want to apply like machine learning and do data science and all this stuff. And I think what I've noticed is when you kind of pigeonhole yourself in that kind of environment, you start to miss on some of the core software engineering concepts. And I saw that a lot, like across the board, right? A lot of data scientists, like not really software engineers, because you don't really do as much of the engineering side of things. And I saw them kind of miss some of that stuff. So any courses that kind of highlight that's important. For me, I didn't take any engineering courses, software engineering courses in general. I mean, I had the technical engineering courses, right? So I got to apply some of that stuff. But as far as my computer science classes, I think a couple of the classes that really hit home for me was CS 2110. I mean, the numbers make no sense to you guys, but it was computer organization and programming or something like that. I mentioned it before. It was the C class, right? It really hit home on how a computer works. We learned a little bit of assembly, logic, and how, for example, an LC3 computer works. I thought that was really cool. At the moment, it doesn't sound super applicable, but really everything that you do kind of boils down to it. Even if you're writing high-level data science Python code, it comes down to how a computer works. If you want to optimize your code, you need to understand how a computer works. If you want to do robotic stuff, you need to understand how a computer works and write C++ code. So that was a big one. The other one's the standard data structures and algorithms. Just gives you a mindset on how to write good code. And another one's just kind of, again, a niche thing. I took a machine learning class. I thought that was really cool. But I took that more for interest more than applying it in the industry right out of college anyway. All right, so next question I see, self-studied to some extent. Yeah, some of it was self-studied. Most of the projects that I did were on my own or through BME classes. It wasn't directly because of a computer science minor. How would you describe your current skill set? That's a good question. I've been actually asking myself the same question. I've learned a lot at J&J, and I know one thing I mentioned is start to figure out where you want to fit in. But if anything, after working at J&J, I've started to question that more. I want to stay in medical devices, that's a given. So I got that out of college, I guess. But having worked in DevOps, I started to really enjoy that kind of space. So now I'm considering like, hey, is that a career opportunity for me, right? Like I got to work on that project and build that out kind of from scratch at J&J. Maybe we can push towards that. So I think that's a good skill set that I've got. Some other skill sets, C++ development. That's a good one to have, like if you want to work in devices, right? So that's a good one. I've been doing a lot of cloud work. So like with Microsoft Azure, like creating VMs and setting up backend services and stuff like that, right? So that's also another opportunity for me. So yeah, honestly, there's a lot, but it's kind of up to me to figure out what I want to do. So, your talk was really inspiring. Thanks. Well, I hope you guys got to take something away from it. Well, we're answering some questions. If you haven't already, oh, okay. Your story really resonates with me. I intend to completely self-study STS. Okay, that's a good question. And I think it's possible. I definitely think it was a little bit harder for me with just a minor to get into where I am now. I had to go through some hoops, right? Like I didn't get to do this right out of college, right? Like I had to work at a company before that, prove myself to some extent before I can get to where I am. And honestly, even working at J&J when I first got hired, I want to say that the company definitely took a chance on me, right? Like they probably could have hired some, great, student out of college like that, majored in computer science, took all the CS classes, did CS projects and all this stuff. But they decided to go with me, right? So I kind of got lucky in that sense. Even though I'd set up and done all this stuff to this point, there was some amount of luck there. So as far as self-studying, it's totally possible, but if you're going to do it, make sure that you build a portfolio. Make sure that you have proof that you're, competent, right? Like that you know what you're doing. And that's going to go a long way for helping you find a career. But having that piece of paper, even if it's a minor, right, definitely does help, right? Like you'll get past like the initial filters and stuff, like when you're applying for jobs and stuff like that. So what's my advice there? Like I said, anything is possible. Go the route that you think is, best for you. And so you said you're a biomedical engineer. So like I said, it's totally possible. I've seen plenty of biomedical engineers get into the space. But if you're going to do it, just make sure to build a portfolio, start to hone in on some of those skills. And you're probably kind of in the same boat as me, like you want to work on medical devices. And if that's the case, start to build a portfolio geared towards that, right? So again, like learn about how computers work, how C++ works. Inevitably, you're going to be using that a lot if you're working with devices. Yeah, that's kind of my advice there. And if you can do a minor even and teach everything else or self-teach yourself everything else, that'll be good for you as well. Cool. Any other questions?
All right. Well, thanks for all the questions, everybody. And thank you again for that. That was a really awesome talk. I really enjoyed it.
Thanks. Yeah, thanks again for having me.
Yeah, no problem.
All right. I guess I'll let you guys get to it. Again, I don't know if you guys